Good morning, students. Last time we have started a new topic, that is topic number 15, Introduction to Polymer Chemistry, in which we have seen introduction, then we have seen the definition of polymers and monomers, and then we have completed classification of these polymers. Then we have started the study of some important polymers, in which we have completed rubbers, in which we have completed the preparation of natural rubber and the process of vulcanization, that is vulcanization of rubber. And then we have started second polymer, that is polyethylene, in which we have prepared low density polyethylene and high density polyethylene. Now we are going to see third type of important polymer is Teflon. Teflon, it is polytetrafluoroethylene, or it is abbreviated as PTFE, polytetrafluoroethylene. Now the raw material used for the preparation of Teflon or monomer used for the preparation of Teflon is tetrafluoroethylene. That is, all 4 hydrogen atoms from ethylene are replaced by fluorine. Therefore, raw material of this polymer is tetrafluoroethylene or tetrafluoroethene. Now we are going to see polymerization process. When this tetrafluoroethylene n numbers of molecules undergo polymerization, this polymerization is carried out in presence of a peroxide. Then here we'll get FCC this is, we'll get polytetrafluoroethylene. This is polytetrafluoroethylene or PTFE. This is the polymer, or it is also named as Teflon. That is, name of this polymer is Teflon. That is, when this tetrafluoroethylene undergo polymerization in presence of peroxide, then here formation of Teflon takes place. This reaction is free radical addition reaction. Free radical addition polymerization. Now we are going to see the properties of Teflon. Teflon is tough and chemically inert. Inert means less reactive or not reactive. Therefore, they are chemically inert. They are resistant to heat and they does not easily attacked by the corrosive reagents. The CF bond present in Teflon is strong bond, and therefore this bond does not break easily by the action of any alkali or acid. Now we are going to see uses of Teflon. This Teflon is used in making non-stick cookwares, and second, it is used in making oil seals and gaskets, etc. Next polymer, or number 4 polymer, is Polyacryl Nitrile, or it is also named as PAN or Erlon. Now, raw material used for the preparation of this polyacrylonitrile is acrylonitrile, that is SC double bond CH H and Cn. This is acrylonitrile. Name of this monomer is acrylonitrile. Now we are going to see polymerization process. When this acrylonitrile, number of molecules of acrylonitrile undergo polymerization. This is also carried out in presence of peroxide. Then here we'll get CH2, CH, Cn n times. This polymer is polyacrylonitrile or PAN, or it is Erlon. This is Erlon or polyacrylonitrile. This is the polymerization process in which this acrylonitrile or number of molecules of acrylonitrile undergo polymerization in presence of peroxide to give polyacrylonitrile or Erlon. This is also free radical formation polymerization. Now we are going to see the properties of this Erlon. Polyacrylonitrile resembles to wool, or this polyacrylonitrile is similar to wool, and therefore it is used as an artificial wool for making blankets, Erlon or acrylons. This Erlon is used as an artificial wool for making blankets, Erlon or acrylons. Five number is polyamide polymer. Now these polyamide polymers are generally known as nylons. These polyamide polymers are generally known as nylons. Nylon is a synthetic linear polymer, that is straight chain polymer, obtained by the condensation polymerization between dicarboxylic acids and diamines. That is, these nylons are synthetic polymers, that is, they are man-made polymers, and they are linear, that is, straight chain polymers obtained by the condensation polymerization process between dicarboxylic acid and diamines. Now first we are going to see nylon 6. Nylon 6 is the first polyamide fiber. Now here raw material used is epsilon caprolactam. Structure of epsilon caprolactam is like this. This is a ring structure in which there are 5 CH2 group in the ring or 5 carbon atoms in the ring. Then CO group is also present and NH group is also present in the ring structure. These polyamide fibers possesses CONH or amide linkage in the polymer. Now here, this is the raw material used for the preparation of nylon 6, that is epsilon caprolactam. Structure of this epsilon caprolactam is like this or this, in which there are 6 carbon atoms in the ring structure, one carbonyl group which is bonded to nitrogen atom or NH group. This is the structure of epsilon caprolactam. When this epsilon caprolactam undergo polymerization, or when this epsilon caprolactam is boiled with water molecule at 533 Kelvin to 543 Kelvin temperature, then it undergo ring opening polymerization. That is, breaking of this ring takes place. Here n numbers of these epsilon caprolactam undergo polymerization to give nylon 6. Like this, breaking of this bond takes place, Then here NH, CH2, 5 times C double bond O, N times. This is nylon 6. And this is polyamide fiber since it possesses CONH linkage. This is nylon 6. Now we are going to see the properties and uses of nylon 6. Due to high tensile strength and luster, nylon 6 fibers are used in the manufacture of tire cords, fabrics and ropes. Now we are going to see second type of polyamide polymer is nylon 6,6. Now raw material used or monomers used for the preparation of this nylon 6,6 are adipic acid. Structure of adipic acid is like this. That is COH, CH2 4 times COH. This is adipic acid. Now in this monomer there are 6 carbon atom. And second is hexamethylene diamine. Structure is, now here hexa means 6, methylene means CH2 group and diamine means 2 amino group, that is 2 NH2 group. Therefore structure of this hexamethylene diamine is CH2 6 times NH2 NH2. This is hexamethylene diamine. Now this hexamethylene diamine also possesses 6 carbon atom and therefore the name of this fiber is nylon 6,6. Now we are going to see the process of polymerization. Now it is a linear condensation polymer, that is it is straight chain polymer obtained by condensation of these two compounds. Now it is two-step process in which first step formation of nylon salt takes place and this nylon salt then undergo polymerization at high temperature under high pressure to give nylon 6,6 polymer. Now here we are going to see the process. CH2 4 times COOH. COOH. This is adipic acid. Now number of adipic acid undergo polymerization with number of hexamethylene diamine, that is NH2 CH2 6 times NH2. Now it is this hexamethylene diamine possesses NH2 group which is a basic in nature because it possesses a lone nitrogen atom possesses a lone pair of electron and therefore it is electron pair donor Lewis base. And this carboxylic acid or this adipic acid is nothing but carboxylic acid and therefore here acid base reaction takes place, that is neutralization is carried out. Neutralization is carried out to form a salt. Nylon salt is formed. Now what happens here? From this OH group, H plus ion is removed. This H plus ion is gained by this NH2 group. That is, this lone pair of electron accept this proton towards itself and similarly this lone pair of nitrogen atom accept this proton towards itself. So that will get a nylon salt. CO minus, O minus CO CH2 4 times CO O minus, that is this hydrogen atom get attached to this nitrogen atom, then NH3 plus CH2 6 times NH3 plus. This is nylon salt. Now this nylon salt or n numbers of these nylon salts when undergo polymerization. Now this polymerization process is carried out at high temperature, that is 553 Kelvin temperature under high pressure. Then here removal of 2n numbers of H2O takes place. That is here from one nylon salt, here this H2O is removed, and here from this H2O is removed. That is 2n numbers of H2O are removed to form a nylon 6,6 polymer. This oxygen atom and this H2. This oxygen atom and this H2. So that will get CO, CH2, 4 times CO, NH. CH2, 6 times NH, N times. This is nylon 6,6 polymer. Formation of nylon 6,6 polymer takes place. Now we are going to see properties of this nylon 6,6. It has high tensile strength and it does not soak in water. And second, now uses used for making sheets, bristles or brushes. Second, used for making surgical sutures and textile fabrics, etc. Next important polymer is polyester. Now this polyester possesses ester linkage and therefore it is named as polyester. The most important polyester polymer is terylene or dacron. Now raw material used for the preparation of this terylene or dacron is ethylene glycol. Structure of ethylene glycol is OH, CH2, CH2, OH. This is ethylene glycol. And second is terephthalic acid. Structure of terephthalic acid is C double bond O, OH. CO, OH. This is terephthalic acid. Now we are going to use these two monomers, that is ethylene glycol and terephthalic acid, for the preparation of terylene or dacron fiber. Now we are going to see the polymerization process. Here this is ethylene glycol, OH, CH2, CH2, OH, and this is terephthalic acid, that is COH, then benzene ring and then COH. This is terephthalic acid. Now when n numbers of this ethylene glycol and n numbers of terephthalic acid are heated at about 420 Kelvin to 460 Kelvin temperature under pressure in presence of zinc acetate antimony trioxide catalyst, then here removal of n numbers of H2O takes place like this. That is here removal of this H2O takes place, and here also removal of this H2O takes place to form O, CH2, CH2, O, CO, CO, N times. This polymer is nothing but terylene or dacron. This is the formation of terylene fiber. This polymerization takes place according to condensation polymerization process. Now we are going to see properties of this terylene. Melting point of this terylene is very high, that is 265 degrees Celsius. Then it is resistant to chemicals and water. Then we are going to see uses. It is used for making wrinkle-free fabrics like terry wool and terracotta. Now this terry wool is obtained by the blending of terryling and wool with each other, and this terracotta is obtained by blending terryline with cotton. This terryline is used as a glass reinforcing material in safety helmets. And third, used for making bottles, packaging containers, etc. etc.